To get started using Docker Client on Windows, we can first click the Quick Start Terminal and get our terminal window going. So I've already done that, and you can see I'm linked up to my default machine on the IP address that you'll see here. Now the first thing I'm going to do is show you some of the Docker Client commands that we can run on the Windows side, and they're the same as in other places like on Mac. But if we just type Docker and hit Enter, this will show us the list of commands we can run. And you can see there's quite a few. Now we're going to focus on the key commands that you need to know to get started with Docker Client here. So we're going to be looking at some commands that you'll see down here like pull. We're going to look at rm, rmi, run, and stop, and a few others along the way here. So the first thing I'm going to do is I'm going to run off to hub.docker.com, and I've already typed in this hello world image that I'd like to find that's up there, up in the cloud on Docker Hub. And so let's go ahead and find this, and you'll see the official hello world image. And this is a very basic image you can use to get started. So if we scroll on down, you'll see a description, some information about it. You'll see some example output of what we would expect if we run it as a container. And then over here to the right, you'll notice that I can run this command. That's a Docker Client command called pull. Really simple to run. You simply say Docker pull and the name of the image. So I'm going to copy that, run on back here, and let's paste that into our terminal window. Hit return or enter, and this is going to pull down a layered file system. You'll see the pull is now complete, very fast because it's a very small image, and now we're kind of ready to go. So it pulled that image down to our local machine. Now how do I know that it actually worked? Well, we can come in and say Docker images. And this will list all the images that we have on the machine. And it looks right now that I have this hello world. It's the latest. Here's a unique image ID it assigns per image. It's created about 12 weeks ago, and it's really small, 960 bytes it looks like. Now from here we have an image, but images on their own aren't really that useful. They're like having a blueprint, but never creating a building. We want to create the building. We want to create the container that can do something. So now I can use the Docker Client command called run, and I can say Docker run the name of the image that you'll see here, hello world. Hit enter there, and there we go. This is the actual container running. And so you can see hello from Docker. This message shows that apparently we're working. So we've done pretty good so far. We have a really, really simple image running, and they have some other info you can check out there if you'd like. That's not super impressive, obviously, but we do have a container. Now, is that container still running, or what happened there? So we can actually see all the running containers by doing Docker PS. And so I'm going to hit enter there, and you'll notice it's empty, which is a little bit weird because, I do have a container. Obviously it ran, but it must not be running. So if we want to list all the containers on the system, we can say Docker PS-A. And that'll show all of them. So we'll hit return there, and there we go. So this is wrapping a little bit, so I'll make it a tad bit bigger. But you'll notice that we have a container ID. That's assigned per container. It's based on the hello world image. There's a command it runs internally, just hello. We created it about a minute ago, and it exited about 55 seconds ago. Now it also gives it a little more friendly alias, if you will. And this particular alias is kind of something you can use instead of the alphanumeric characters you can see over here for the container ID. All right, so we've now run the container. We can see the container, but it exited. So this is a different container. This isn't one that you run the container and it stays up and running like a server. It just runs and then it just shuts down. So it's a very simple hello world type of example. All right, so let's get rid of this container then. We know it works, but we really don't need it anymore, and you'll probably never ever use it again. So we're going to do another Docker Client command called remove, and this removes containers. Now I'm going to go ahead and use the container ID, but I really don't want to type all this. I know when I first started using Docker, I didn't realize that you don't have to type the entire container ID. So I went in and typed the whole thing though, but you don't need to. We can actually, in this case, we only have one, so I could get away with 24. I can get away with 2 if I wanted, but let's go ahead and do that. And you'll see it echoed back out, the container removed. Now let's make sure it worked. We'll do Docker PSA again, and everything's gone, you'll notice. Okay, so the container's gone now. Now, what about the image? Now, the image is still there, and I probably don't need that on my system, so let's clean that off. And we can do that and remove it by doing docker rmi, remove image. And then, just like we did with the container ID, there's an image ID here. So we only have one, so it's pretty simple. I'll just do like 0A. And now it just deleted that layered file system. Now, if we go back and do docker images, you should see that it's completely gone. So now we've downloaded the image or pulled the image, we've run it, the container immediately stopped, we removed the container with the rm command, and now we just remove the image. So now there's really no trace of this on our system, and that's a great feature that we're going to talk more about in a moment with Docker in the development environment. So that's an example of how to get started with those commands. Now let's take a look at how we can pull a more robust image from Docker Hub and get that up and running on our machine. So if we go back over to the Docker Hub site, I can come in and search for Hello World, but for the Nginx. And if you saw the Kitematic demo earlier in the course, I'm going to do the same thing, but we're actually going to do it using the Docker Client tool. So I'm going to come in and we'll just search for Kitematic, and we can just do hello-world here. Should pull it up. And there it is. So we can view some information about it. There's not a whole lot on this one, but it's a simple Nginx reverse proxy container. And you'll notice over here again, just like with the Hello World image, I can also pull the Kitematic Hello World Nginx image. So let me make sure I grab that whole command. And I'm just going to come on back and paste this in. So we'll paste in the docker pull command. And this one will have a little bit more. So this is going to pull down, again, the layered file system. You'll see this will start to fill in. It's still pretty fast. All right, so we're ready to go. So I'm going to do docker images. And there we go. We have the Kitematic Hello World Nginx, latest. There's the image ID again, and we can see the age and how big it is. So this one's a little bit bigger. Looks like about 8 meg or so. So the next thing I'm going to do is we have the image. And just like with the Hello World image, I want to go ahead and run this. So we would do the same thing. We would say docker run, and then we would put the image name. Now, because this is an actual server, it doesn't just write simple log output. There's a little bit more that we need to supply here. Now we have a Docker machine, and in fact that machine IP is shown right up here because I'm going to use it in just a moment. We saw that when I started the Quick Start terminal. And that machine needs to be told what port do you want to call to come into on the machine. And then we have to tell the machine, okay, well, once you get on that port, we're going to do port 80. How does it call into the container, and what port does the container actually have? And I like to think of it as a bubble around the container. And on the outside of the bubble is the machine port. And then it's going to call a port that's the actual Nginx port that's in the bubble, or in the container, in other words. So let me show you how this works. It'll make a little more sense. So I'm going to say -p, and then we're going to do 80, and that's going to be the port for the machine, colon, and then that's going to say I want to forward from port 80 on the machine to port 80 in the container itself. Now, if we wanted to do maybe 5,000 on the actual machine, but 80 on Nginx, we could do that. But Nginx is typically used as a front-end type of reverse proxy server. It can serve up static files and then forward requests to more complex back-end servers like ASP.NET and Node.js and PHP and things like that. So we're going to do 80 to 80, and this will forward it. And we're going to say docker run on this port on the machine and on the container, and then we have to put the name. So it's going to be Kitematic Hello World Nginx. All right, so now that we have that in place, we can go ahead and start up this Nginx server. So we'll go ahead and run that, and there we go. It looks like that container is now up and running. So what I'm going to do is leave that up, and I'm going to right-click here on our Quick Start terminal. I'm going to start a new terminal, and that'll link us up to the default machine again, and there's the IP address. And now let's see, what do we have as far as containers? So we're going to come in and we're going to run the docker ps command. And it looks like we do indeed have a container, and you can see that it is up for about 23 seconds, up and running. There's the image it's based on. there's the container ID, and then here's the port forwarding I was talking about. So the IP here just is kind of generic, but this will be the machine IP :80 that forwards to port 80 in the actual container itself. Now that container is up and running, as you can see here, and it looks like when we started it up, we have this start.sh that the Nginx image actually had in it, and that actually started up the Nginx server. So I'm going to run over to this tab now, and we're going to try to refresh here. We're on port 80, so obviously I don't have to put, :80. We could, but I'm just going to hit enter, and there we go. So we now have on our development machine an Nginx container up and running. Very cool, because I didn't officially install anything from the Nginx site. We're just using obviously Docker images and containers here. So I'm going to run on back. Let's bring both of these back up. You'll notice that a request was made here. It shows the GET request was made. It was a successful 200 and some other information about the browser. And then if we come on back here, you can see that we're back where we were, and we can see that it's up and all that. So now what I'm going to do is let's go ahead and try to stop the container. So we'll go ahead and, not to confuse terminals here, let's go ahead and leave this one up. And I'm going to type docker stop, and then I'm going to take the container ID over here. Now, again, we don't have to type the whole thing. In this case, I could say, for instance, D7. And that's going to stop, using the Docker client tool, that particular running container. And this will take just a moment for it to stop. All right, so once it echoes back out the ID you typed, that pretty much means it stopped. So if we type docker ps, we shouldn't see it, and we don't. But if I do docker ps-a for all, we should see it. But you'll notice that now it says it's exited about 14 seconds ago. All right, great. So we now have a running container that we stopped. Now we've seen that because it stopped, we have to do the -a switch again to see it. And now let's go ahead and clean it up. Now this is one of the more exciting features, I think, from a development standpoint. Instead of installing a server on your physical machine, whatever it is, database server, web server, normally when you uninstall it, it seems like there's always a few files left over. But in this case, because we're using images and containers, we can use our normal Docker client commands, and I can say remove, give it that D7 container, and now if we do docker ps-a, you'll notice everything's gone for the container. So all right, that's great, but what about the image? Let's do docker images. We still have the image. Now normally, if you're going to be reusing this image to make other containers, you'd probably just leave it if we do it a lot. But in this case, let's just say, hey, I'm done with it. I really don't want it on my machine anymore. I've maybe tested something and everything's working great. Well, just like we did earlier, we can do remove image. And in this case, the image ID has this 385. So we'll go ahead and do that. That completely deletes that image. And now if we do docker images, you can see we're clear. And docker ps-a, of course, we're clear on containers. And this is pretty cool, I think. I'm a little bit picky on my development machines, and I like to keep everything really clean. And so when I'm done with something, I really would like all traces of it to be removed, and now it is. And I think this is a very, very cool feature for development that I literally can get, whether it's a database server, a server that's a reverse proxy like Nginx or others, up and running quickly on my machine without a lot of effort, just a few commands. And then I can completely remove all traces of it using these Docker client commands. So that's an example of some of the different Docker client commands that you can run on your Windows machine.